as individuals, we care about this a lot. Our data is out there, and it's not always clear how, when it's being used, and understanding what the tools and techniques are for improving your ownership over privacy, I think is really important. Just as individuals, in our digital era. Take that one step further, and businesses are responsible for this data and wanting to share data and do work together in a way that's privacy preserving. It turns out to be a really fascinating and complex technical space. So we'll have some opportunity here to learn about work that's happening. Specifically, James and Marcy can walk us through some of their work in Dataverse and OpenDP. So I think we'll start with James and Marcy. Can you each just introduce yourself quickly? You'll have to go off video mute and off audio mute. And just James, we'll start with you, a quick introduction, who you are and high level.
Yeah, hi, I'm James Honaker. I'm a research scientist at Harvard. I've been working most of my career in statistical software, and most recently in how to make statistical methods open to researchers who want to work on sensitive data but can't get access to the underlying data through differential privacy, which is what I'll be talking about. And I am also a research scientist at Facebook.
Thanks, James. And Marcy?
Yes, hello, everybody, and thanks, Chris. I'm Marcia Crozas. I'm the University Research Data Management Officer with the Harvard Information Technology, and also the Chief Data Science and Technology Officer with the Institute for Quantitative Social Science at Harvard University. And I have been, as I'll be talking about today, I've been working on a lot of issues related to data sharing, accessing data, making it more discoverable for research, and building projects such as Dataverse and OpenDP to help with that.
Awesome. I look forward to
and also
go ahead.
No, also the importance of open science, making working with open source platforms to make that possible, but at the same time, obviously working on privacy issues when the data needs to be protected. So we're combining, but we're trying to be as open as possible, but also being responsible for protecting data, but still using it for research whenever, in the ways that is possible.
That's one, like I said, I look forward to it too. It's a nice follow on from some of the earlier topics we covered, which were in the vein of reproducible results. So openness is critical to defining how you do your, describing how you do your experimentation, and then consistent access to data is also a critical part if data is what you're experimenting with. So I think we have a nice lineup here. So James, can we start with you? And I know you prepared some content to just give us some overview of OpenDP, and then after that we'll switch to Marcy and her slides. Does that work?
Can I also just quickly introduce our illustrator for today?
Oh, of course.
See, when we're not presenting slides, you'll see Mo Duffy, one of our colleagues, drawing what is happening, which we think is a really cool way to
I love it.
Encapsulate the discussion. And we're going to have all of these finished sketches up on research.redhat.com after the event.
Awesome.
Thank
you, Mo.
That's really. I promise you, we did practice this, and sorry for that difficulty.
Looks good.
So I'm gonna talk about from my own part. I'm gonna introduce a little bit about differential privacy, which Chris has already talked about, and it's an honor to come before Adam, who's a dear colleague and obviously the innovator and sort of one of the founding fathers of this literature. It's also it was a fantastic honor to be invited to speak about this. This has been a project that's been really near and dear to my heart and central to my research for about 6 years. And my daughter was born just as I started this project. So as she gets older and older, it reminds me how much work we've been doing on this from the very, very beginning. I was working with Mercedes. It's really also an honor to pretend to be a peer to Mercedes here, when in fact, really, I learned a lot about software engineering under her tutelage. So we're now at opposite ends of Harvard, but I look forward to talking about the ways we still work together. And the way that we work together right now is through this merging of the OpenDP project, which is what I'll focus on, which is the underlying technical library for bringing privacy preservation in a rigorous way to statistical analyses or to data queries or to machine learning models or whatever it is that you're trying to compute on data, and show how this can be integrated with other kinds of data platforms or data portals, Dataverse being a leading example of what it is we're able to do. Okay, so OpenDP, we have a number of websites, and I'll show you some project resources if you get interested in this. Hopefully you do, that you can look at more. This is very much a community-oriented project. So if you are at all interested in this, this is not a Harvard project. This is something of a Harvard incubated location by which we're trying to bring together the entire community, not just of researchers who work in privacy preservation, but also end users who need privacy preservation for their research to go forward, and for intermediaries, for people who are building systems and have users who want to consume privacy and data that they need to protect. Okay, so I'll talk about that in more detail. Let me first explain one intuition about why this has become such a fast and important evolving field. Before, say, this millennium, there was this sort of operating assumption that as long as we were aggregating things would stay safe. That some form of stripping out proper names or other personally identifiable information and some degree of aggregation was sufficient for privacy preservation. But what we've learned is that is almost guaranteed to fail. That is, there is always an attack that's probably going to exploit that approach, that simplifying assumption. And this classic paper by Kobe in 2003 showed that if you release too many statistics on a data set, or if you release them at too fine a level of precision or of utility, there will be a way to tease out and re-identify information from the underlying population. You will leak information about individuals, maybe allow a reconstruction of an individual's data, or at first learn whether or not an individual is even in the data set. And that's not just about simple queries like asking for means or summary statistics. Even what look like very, very complex objects like statistical models or machine learning models or neural networks. In fact, these things have proven to be even more fragile. They're much more vulnerable to these exploits. Okay, so and just as sort of an intuition for why this is true, let's say I've got 21 people. It's probably more like 200 people watching this talk. And we knew that the mean age was 23.7, okay, or 23.67. It might seem like that's an aggregate quantity. What can I learn about any one person from that? But if I allow myself to ask other queries, for example, somebody says, oh yeah, I didn't want the mean age of everybody watching this talk. I want to know just the mean, I want to know the mean age of everybody watching this talk, not including James who's presenting. Then the mean would drop. Okay, and again, that looks like an aggregate quantity, but quickly you just do a little bit of algebra and you work out, okay, the only difference between those two numbers is my age. Therefore, I can just uniquely work out what my age must have been to create that difference. And something like this is sort of at the heart of every large catalog of possible exploits that are possible now, given the amount of computational power we can throw at data sets and data portals. And all of these successful attacks can basically extract what all the underlying initial information must have been from seemingly innocuous queries. Okay, so this is increasingly a problem as statistics become repeatedly released over time, as users can generate their own models, as machine learning models get complicated. So what do we have? The only sort of formal way we have of guaranteeing in a gold standard way that can't happen is this definition called differential privacy. Differential privacy is a mathematical definition. An algorithm can be proven to either satisfy differential privacy or not. If it does satisfy differential privacy, then there's things that we can say are impossible with releases that come out of it. Here's the way it's going to work in a standard setting. Okay? If we have a bunch of trusted data analysts who want to ask queries on sensitive data, they're not going to be allowed to see the raw data themselves. Okay? Instead, they're going to be allowed to ask questions of the data to a trusted intermediary called the curator here. So I have my analysts on the right, and they're asking questions of the curator. The curator is able to see the raw sensitive data. Okay? However, the curator doesn't know if the people asking questions are legitimate or well-educated. Maybe they're making accidental queries that might leak information, or if they're actually malevolent. The curator is going to assume the worst. And so what the curator is going to do is not answer any question that comes from the data analysts exactly. Typically what they're going to do is they're going to reply with an answer that meets the definition of differential privacy. And what that's going to mean typically is they're going to answer the query and add a small precision calculated amount of noise on top of the query. Okay? So we're going to, instead of giving exact answers, we're going to give out inexact answers. We can add a little bit of noise, and it's going to be precisely tuned to be the smallest amount of noise we can give and still give the guarantee of privacy to the underlying subjects. And what does privacy mean here? It means that if I actually have an adversary and there's a data set, the distribution of answers that are going back to that adversary should be indistinguishable. If I take any one observation in the data set, take any one person's individual information, and I remove it entirely, then the distribution of answers that are coming back, because they have sufficient noise, the adversary cannot tell if the data set had that observation or did not have that observation. The adversary cannot tell. It's epsilon indistinguishable, those two things. And if they can't tell if you're in the data set, then they obviously can't learn anything about your data set. It also guarantees that if I say gave different answers, or if an individual subject in the data set gave different answers, they also would not be able to learn. Okay? And so that's a very strong privacy guarantee if I'm an individual subject thinking about contributing my information into this data set. If it's true that any adversary gets exactly the same set of answers, whether I'm in the data set or not in the data set, then I may as well contribute my data if I think there's some public good or research purpose to this data, or I'm being remunerated or something like that. Because the adversary can't learn anything about me. They can't even learn if I'm in the data set or not. Okay? So there has been this increasingly in the last 5 years, we've seen applications by leading industry, tech giants, creating very, very bespoke solutions harnessing differential privacy to answer specific questions that they're interested in. Okay, and however, they've all built code bases from the ground up, from scratch. You know, and differential privacy is rooted in cryptography, and one of the things we all know from cryptography is that you should never roll your own cryptography. It's very, very hard to get, even if the algorithms are simple, getting implementations that match the algorithm and don't have side channels is extremely hard. So the goal of OpenDP here is to bring together all of the researchers who are working in differential privacy and have them collectively form one underlying trusted code base that works for everybody. There are different research agendas. There are different slight definitions of what differential privacy means or whose privacy it is we're trying to protect. So we're trying to build one underlying library that all researchers can contribute to. And that means that we'll be able to translate ideas out of the research literature into practice faster. And nobody will have to start from scratch every time they want to build a data portal. They'll be able to use trusted code that the entire community has looked at, that's been vetted by everybody, that has a very, very high bar to get added into the library. Okay, that we think is going to speed the adoption of this, not just by by industry giants, but by everybody else who needs this in their own systems, or users who need to consume these ideas, and also speed the translation from research ideas into practice. Okay, we had a recent community meeting where over 300 people expressed, joined and listened in on sessions to learn how they could be involved, either contributing their research into the library or building the surrounding orbit around the library of components that you might need to build out an effective system that uses this as part of their technology stack, or statisticians saying, yes, this is great, it's a great theory idea, but here are all the things in practice I would need in order to be able to use this in my own research. I'd encourage you, all these plenary sessions are available if you'd like to see some more about that. The underlying thing that I think is of most use to this talk and to this audience is that at the heart of this, there's a library of algorithms built out of components that are each individually differentially private. And if you knit them together, you can get larger and larger or more complex queries, more complex algorithms, because differential privacy has this computability property that if each individual component is differentially private, then the entire algorithm is differentially private. So this programming framework allows people to contribute components and knit together components with other components to build query libraries that they might want. It integrates with things that it's planned to integrate with things at scale. So SQL and Spark, we've got examples of running queries there using this library. The underlying library is written in Rust, which is a very sort of popular up-and-coming library, even if it's not very widespread yet. The reason we use Rust over C is maybe something we can talk about in the session, but it's sometimes been described as C++ only fixed, which is to say it's extremely memory safe. It's a functional language. It's very easy to reason about what exactly the the code is going to do at any particular point. It doesn't have these things like dangling pointers or memory races that you get in C and C++. So this makes it very, very concrete that we can reason exactly what a function is going to do when it's executed on data in every circumstance. And that provides the ability to reason about this code and make sure that it's actually differentially private. However, if you say, oh, I can't use Rust, we've opened up bindings to other languages, in particular simple Python bindings that make it look like you're writing native Python, and yet you get all of these underlying queries and algorithms that have been built by the community. So you want to run your statistics. If they exist in the library, you can call them through these Python bindings. Okay. Again, if you're interested in the project, I will try to make sure to throw this up at a couple other times during the talk when there seem to be lulls and nobody can think of anything to say. But I would encourage you first to go to the project, the OpenDP community pages, and then maybe take a look at some of the white papers that are there that speak about all the different ways to be involved at different levels and on different components. And everything that's being written here is open source under the MIT license, so the code is all available through GitHub. Thanks.
Awesome, thank you. So that was sort of if you're not familiar with differential privacy, now you're an expert. Quick dig into some of the details, which hopefully we'll have a chance to talk a little bit more about in some Q&A. But before we do that, I think it would be great to hear from Merce about this, put this work in context. So hear a little bit about the work that Merce is really a part of, bringing not just differential privacy, but also the big data picture and the Dataverse. And then we'll switch to some Q&A and see where we can take the conversation. So I will turn it over to you, Merce, and you've got the floor to present your content. Thank you.
Thank you. Thanks a lot. And first, it was great to have Jim just excellent, as always, an excellent introduction to differential privacy and what OpenDP vision is. So, but I'll bring that in a more user cases context. So, I will talk about how do we put that in practice with some of the platforms that we have now for data sharing. So first, what we want to do for OpenDP in terms of use cases is to be able to support the analysis of sensitive data from data that comes from academia, from the research that is collected by researchers in universities and research organizations, data that comes from government agencies, and data from companies. So in particular, within research, there is an increasing number of data repositories that are used to share the data that has been collected, observed, part of the research life cycle, the research studies within universities and within academia, and those usually do not support sensitive data. So we want to be able to provide support of sensitive data and be able to provide privacy-preserving access to this data. Then we also want to be able to to support, well, to provide a use case for government agencies, data from those agencies that are usually, sometimes they can be public, but there's many cases that are considered sensitive data. But how do you provide access to research, to data-driven policymakers, or to the broader public in a way that is safe? And then also from companies, there are, well, increasing number of companies, are practically all of them are collecting data about the users, the customers, and other data that could be useful for academic researchers, and even for their own companies to share from one group or one section to another of the companies. But how do we provide access to those data in a way that again provides privacy preserving tools that allows to do the analysis without accessing the data directly? And this is becoming extremely important because a lot of the research data, the research in social science, in public health, needs data from companies to be able to have a complete analysis of what society, how it is behaving, what are they responding to something in a way, but there is a lot of limitations at present about how to access that data for research and for improving situations that it goes all the way to pandemics as we're living now, to other issues related to social well-being. So that's an increasing use case that we want to be able to support. But let me give you a little bit of a description about what Dataverse is and what have we done so far and what we're planning to do with OpenDP in the picture. So the Dataverse is a software platform, an open source software platform that powers data repositories. So you can take the Dataverse code and set up a data repository to be able to share data. And it shares data in a way that follows many of the standards for data publishing. And it provides persistent identifiers to data sets, descriptions of the data sets, metadata. And so it provides a lot of the support for sharing data in a way that is discoverable, that is accessible, that is usable, and also interoperable. So when we put that as a finding, accessing, interoperability, and reusability, we have fair data, right? So that's why we say we support fair data sets. Dataverse has 61 Dataverse repositories worldwide. They are set up at many sites, from research organizations or universities or the institutions. And there is a large community of contributors to the code. At the same time, we have, as an example, one of those repositories. If you see one of the dots in the map here, is at Harvard. And Harvard University have a repository that is open to all researchers for depositing and sharing the data and for accessing data sets that are public, but also being able to deposit data sets that need to be restricted, but they are still discoverable through the searching tools of Dataverse. So in this, for the Harvard Dataverse, currently we have 100,000 searchable data sets. Those might have multiple files each, data files and metadata. There's been 19 million downloads of those data sets, of the files in those data sets. And as I said, it's open to all researchers and to all research fields, not only to social science where it started, but also to public health, to medicine, to natural, to physics, to law, to business, to business data. So there's research data in many fields. So what we're bringing this Dataverse platform, which is already mature, with the new OpenDP, and what we want to be able to do is first enable search and exploration of sensitive data sets in the repositories in these Dataverse repositories without having to access the original data, be able to produce rich statistical summaries of these data sets so that they can be shared widely. And of course, with all the privacy preserving guarantees that the differential privacy gives. We want to be able to generate differentially private synthetic data that reflects many statistical properties of the original data set. So we want that so that what we publish, the differential privacy releases that we provide through Dataverse to be useful, to be reusable and be meaningful statistically to do research. And we want to allow also approved researchers to use OpenDP queries and the type of queries that James was talking about, and providing an interface that would be able to run more additional differentially private queries that are not the ones that we release by default from a data set. And Chris mentioned reproducibility. We want to be able to facilitate reproducibility of research of sensitive data sets, which is now very difficult because obviously the data is not open, and we're saying whenever possible, we want to make the data open and the code open. But in the cases that are not possible, we want to be able at least to provide enough queries and access to analysis of the data set in a way that is with privacy protections, but that can still reproduce the final results of a research study. So just an idea about, well, a review of what we mean by, or how we categorize non-sensitive data versus sensitive data. So we, this is based on a project called Data Tags. And Data Tags is based on the levels of data security that we use also at Harvard. So we consider non-sensitive data, the blue data sets, the green data sets, and yellow data sets, but they still might need to be restricted. So the blue is publicly open, the green is open, but you need to register to access. Yellow is restricted, but it doesn't have sensitive information as you would think as a HIPAA information, for example, for clinical data or patient data, basically, or other data that is formally considered sensitive, but still you want to protect it because there might be a risk of making it open and being able to, for example, if it's been anonymized, be able to re-identify the data set. And then we have a set of tags that apply to sensitive data sets that are orange, red, and crimson. And those require a data use agreement to access the original data set. What we want to do is OpenDP is allow these orange, red, and crimson data sets that will be supported will be deposited or will be made available through the Dataverse platform, be able to access analysis of those data sets through OpenDP or queries or releases, differentially private releases of those data sets through OpenDP without accessing the raw data or the original sensitive data. So how do we put all those things together or propose to put them together? So we have the Dataverse is a public repository, meaning even if we have data files that are restricted, still anybody can go and search what data sets exist there. So it's discoverable in a public way, right? And the more public data sets are the blue, green, and yellow, as I mentioned, right? But when you have an orange or red data set, for example, you would have it in a data enclave that it's connected or it's trusted by Dataverse, and so in this case, the metadata would be in the Dataverse repository, and the actual data files, sensitive data files, would be in the enclave. And then OpenDP is part of the picture by being able to run these differentially private queries in a secure compute environment, right, that that has access to the raw data, to the sensitive data in the enclave, and can release these differentially private statistical releases to the data user through Dataverse, as is the user finds that data and then requests that query through OpenDP. OpenDP sends back the query to the user. So this is the high-level architecture of how that puts all these pieces together in a way that the user can find a data set that would not be able to access, but can be able to run queries, differentially private queries through OpenDP, and be able to get those queries back, and still be able to make use of the data for again, for research, for getting insights on the data set, without having to compute directly on the sensitive data. So this is the end of my slides. I'm gonna unshare this, and I'm happy, and just both James and I to answer questions. Thanks.
Great. That's been really useful. I've talked about this notion of basically sharing data without sharing your data, without sharing access to your data. And I think about it a lot, again, as I mentioned early on, part of it is just personal. We're all out there, we're engaging with, we have a digital footprint that's not well understood necessarily. But also the world is built off creating insights out of data. And increasingly, I mean, not exclusively, but increasingly. And there's real value in that, especially when we talk about health sciences and the pandemic research today, a really great example, or contact tracing, other good examples. If we go down to the bottom of the stack, I'm, as a general newbie in this space, could you help at least me, James, understand how we could segment what differential privacy does compared with, say, secure multi-party compute or homomorphic encryption, where, you know, kind of vaguely in the similar space, but trying to solve different slices of the same problem domain?
Yeah, that's a great question, and those are very, in some sense, hopefully complementary technologies. I say hopefully in that it's presently somewhat hard to integrate them, but it is a focus of research, including people like Adam here and many others. What homomorphic encryption and multi-party computation tend to achieve is input privacy. That is, you can create privacy on the data as it enters the system, or computation privacy. That is, you have privacy as the computation is actually occurring. When you get to the final answer, though, they give you the right answer. And that might seem like an advantage or a blessing of those technologies, but it's also a curse, which is, you know, the underlying idea of the attacks that I was talking about was, if you give correct answers out into the world and you give either answers that are too precise or too many of them, people will be able to back out, reverse engineer what the data must have been to give those answers. So differential privacy gives output privacy. It says that once once this data has moved and once the computation has happened, then when the answer is released to the outside world, privacy is still preserved. And so you can imagine systems, you know, like end-to-end systems being, you know, homomorphic encryption for the data, then possibly that's when the join happens, or MPC to compute an answer without having to share the data in the first place, getting to the answer and then having a differential privacy layer so that you can take that answer and broadcast it to the outside world and still have privacy.
Oh, thank you. Actually, I never quite put it together that way in my head, so that was informative to me. One of the things that I'm curious about is, I'll give you two examples, and then see if you can help me understand where OpenDP and or Dataverse are helpful in these areas. One would be Strava, and one would be Google Maps. And in the Strava case, a fit set of folks in the Army were out jogging around their Army base, inadvertently exposing the destination, the location of this Army base. And then separately, Google Maps, strips personally identifiable information. But if you look at somebody's daily commute, you can certainly start to figure out who they are. It starts in a neighborhood that looks suspiciously close to where Chris is rumored to live and seems to go to an office suspiciously close to the Red Hat office. And so my question is, in data science, there's often a data collection stage and then a data cleansing or data engineering stage to prep for doing your data science. And is there a thinking process that we need to consider that is about what we might accidentally be leaking as a side effect of the data that we're gathering, that you can be clear in your description of the average age? When you remove you from the sample set, it becomes really trivial to reverse engineer your age. Are there things we have to think about in terms of when we're creating the data sets or how we expose them that includes privacy that's not directly addressed algorithmically with something like OpenDP? Is there something in that we're missing that we could potentially still be leaking even if we're using great secure techniques?
Yeah, temporal spatial data is a really clear issue where this is highly of concern. Like as you mentioned, if you know somebody's location in time, like where you were, just a cell phone tower resolution, which is fairly aggregated, right? At 3 points in the day, that's normally a unique fingerprint for an individual. So if I know 3 places where you were, Chris, during the day, then I could probably re-identify you from a data set that had like location data in it. And that's not a lot of information to know about an individual to then tease who they were out of a data set. So it's that's a clearly it's a real struggle. It's a real concern. Some of the broader questions you asked though about like the military base case is starting to bring up the really hard question about whose privacy do you want to preserve? Do I want to preserve each individuals in the data sets, or do I want to also start to mask larger and larger groups? And if I try to mask larger and larger groups, then am I saying that I don't want to be able to answer questions about large subpopulations? Basically the question of, is there a military base at this location, is not a question about any individual person's privacy. It's privacy of a very, very large group. And if you try to obscure privacy at that level, then you might be obscuring lots of other population level trends that are actually interesting and legitimate research questions. So these are all difficult questions. I would like to pass off to Mercedes about how we decide which researchers we use and those kinds of things.
Yeah,
but they're very much within the domain of what we can address with differential privacy, but really only at the individual level.
Right, and yeah, they're very difficult. I mean, I think that it's also at a high level, we maybe should be more aware of what questions we're trying to answer, right? And from the beginning to see, and then what is that we're collecting out of these questions. Useful in a more generally for humanity, and in a way that it's at the individual and at the societal level. But it's there's not just one answer to that, but it just means we could also be more aware that there is no need to collect everything if the answer that you're looking, the research question you're looking for, doesn't need that information. So you're avoiding some problems from the beginning. But then once you collect it, if there's still an issue like James was pointing out of re-identifying, even if you think that data is protected, might not be, and then differential privacy. I think OpenDP can play a role or helping to how to make use of that data.
I do want to follow up on one question you brought, which I think is a really clear point, which is in a privacy preserving world, in a world where we understand the amount of the complexity and the detail of data that's being collected about us, and we're sensitive to having high ways of using that are good for society, but avoiding the risks in re-identifying individuals. It does change fundamentally the way we're trained to think about data. There's no way to use these systems and not adjust the workflows that people are trained. So as a statistician or as a data scientist, we're typically trained day one. Make sure you put your hands in the data. Make sure you look at the raw data and that it's what you think it is. Draw some histograms of columns of variables. Look at some rows and make sure that they make sense to you. There's no way to do that if you don't have exposure to the underlying data. And so learning new workflows, learning new intuitions about how you're going to approach data and ask queries. I think that does make people uncomfortable, but I think it is a necessity of the sort of the data-rich world we're in. It's surprising that now that we have more data, data becomes in some sense harder to use.
Yeah, it's a very good point. It could be part of the training, right? If we learn how to, if we teach how to do it from at the point that students are studying that, so that would be great.
It sort of opens up a question for me. I think best understood or best articulated in the context of machine learning and machine learning models, and the lack of clarity and understanding of what happens in a decision-making process inside a machine learning model. And so there's questions around how you can verify or prove why a model made a decision. When you don't have direct access to the data, are we subject to a different kind of adversarial concern, which is maybe in the curator pattern? Is the curator malicious and feeding you incorrect results? I mean, what do we do when we don't have access to the data and draw our histograms to still be convinced that we're getting valid results?
Yeah. Wright, sorry, did you want to?
No, well, go ahead, James. Yeah, it's good.
Yeah, so the curator model is very, very common. It's not the only model of differential privacy. Some of the earliest implementations that you saw from, say, Google's Rapport or the Apple iOS used another version of differential privacy, which is called local differential privacy. There, what you're doing is you're adding noise at the point of data collection and then building data sets that themselves inherit differential privacy. That's another strategy if you don't want to use a curator or you worry that the curator themselves is not trustworthy. So there are flavors and different architectures here that can accommodate different trust models or different threat models. Just as a broadest answer.
Okay. And Mercedes, did you have a thought in this space? Maybe it's a concern for the Dataverse and how you're presenting data to scientists doing research on health sciences or
right. Yeah, we are reviewing a number of use cases that would be of interest, right, for research, and in some cases it's not always true that nobody can have access to the raw data. There might be some a group of collaborators that have collected the data because they have the under data use agreement or for any reason they do have access to the data. They can they understand very well the data set and can create queries. Differential privacy statistical releases to be used by anybody else, but in a way that they can validate that they are useful and they are not. So that would be one use case that the curator is well informed and it's in some way the data owner and produces these releases. So there is. I think that we're then we're eliminating that tension that it's either nothing can be accessed for research or everything can be accessed, right? There is something in between that you can access some differential private releases that are considered valid and useful and statistically meaningful. I don't know if it addresses exactly your question, but it's just one of the use cases we're looking with Dataverse that would address. I mean, in some other cases, they might be need to add additional tools to help with this validity, right? But at least some use cases will plan to address these issues.
And I want to follow up on Mercedes' point, which I completely agree with, but tie it back to a little bit more to Chris's question as well, which is this idea that at first it looks hard to do validation from this perspective, but your question of, okay, maybe somebody told me this was a differentially private answer, or a curator gave me a differentially private answer, and now I'm not sure, so I want to go back and actually be told, is this answer that I was told, is it close to the truth? Is it a usable answer? Does it have high validity? Is it going to make good predictions in the future? That's very tied to the earlier questions that Hugh brought up when he was introducing the whole session, which was connections to replicability. Maybe some scientist has said, I have private data, you can't look at it. Here's the answer that I found in the private data. It's very, very similar. You might think, okay, well then you're stuck. How do I ask a curator, this person released this answer, does it look correct or not? But this idea of validation is actually a very simple thing to do and a very powerful thing to do through differential privacy. If I ask a data set, what is the mean of the data, then my information can affect the mean a fair amount. Or if I ask for a model or a neural network, one or two outliers could affect the data a fair amount, and there's a lot of sensitivity, and I have to add a fair amount of noise to mask mean. But if I simply ask the data set, yes or no, is the mean pretty close to this number? Or was this answer that was published in a scientific paper pretty close to the truth? Or is this model going to give me yes or no? Is it going to give me good predictions? Is it going to give me predictions within this level of accuracy? A yes or no answer can't really be affected very much by my own individual data. So that yes/no answer is going to be fairly low in noise, or going to leak very, very little information. So it is absolutely a strategy of differential privacy to simply validate things that people think they already know, and that's very, very helpful for using differential privacy to check work that's been published, or using differential privacy to aid in reproducibility and otherwise sensitive data where you would shut people off.
Right. So maybe on this similar topic, in the chat, Alexei Rusakov asks about, I'm imagining a scenario where you've got one body of data and multiple curators accessing it. And is there a way that you can game the system to kind of remove the noise by asking multiple curators same questions and starting to triangulate in on the real answers?
Yeah, that absolutely is a threat. That is the hardest thing is that the differential privacy presently tackles, and it does tackle it successfully, but it is an added layer that you have to think about in system design. It is, as I said, the original result of Diener and Nassim is you cannot ask too many queries of a data set or ask queries with too much precision. Otherwise, you will leak the individual raw data. And asking multiple curators the same question is a form of that. So the way differential privacy stops that, either from asking the same query over and over and over again to the same curator and then trying to average them so that the noise collapses, or asking multiple curators, is this concept of budget tracking. Every time I ask a question, I'm spending a little bit of some sort of mathematical parameter called my privacy leakage budget, or my privacy loss budget. And I get to ask questions until that budget is expended, and then it's done. So if there are multiple curators, they have to know what my total expenditure is across all curators, otherwise the system would break down. Or if there's one curator, it has to know what are the queries I've asked in the past, calculate my budget across them, And again, we talked about like things that are very, very uncomfortable to analysts who are used to sort of wringing the last sort of statistical result out of their data set before they go and collect the next data. It does mean that when your budget is done, that is the end of your access to that data set. You know, that's troublesome to some people who want to say, but wait, there's still more answers I could have gotten out of that data. That's sort of, well, that's what privacy means now, that there's going to be a time where we cut you off on that data set. The only upside to that, I'll say, is that as a statistician, as a scientist, I don't care about any one data set. I don't care if the tap is turned off to one data set. I care about population level truths. I care about things that are true in society that I am learning about the world. So when my budget is exhausted on this data set, it's time to go collect the next data set. Or it's time to find the next data set in Mercedes Dataverse that can also start answering those questions. And that's the privacy approach.
Yeah, and the only thing to add, Jim's answer the question, but just in terms of how we connected it with Dataverse and what we're deploying for OpenDP, and so is that we're going to take it in also in phases that so some of those use cases I was describing is not going to need that, because there will be a release that it will be created by the data owner in a way, the data, and that will so there would not be an increase on the privacy budget. Once we allow for any queries from various curators, we will track that privacy budget and will be part of the tool, the OpenDP, what we call the commons or the libraries, the main the tools, the tooling that goes with OpenDP to be able to implement that when you integrate with a repository.
Well, we're kind of near the end, but I'll ask you each just a quick, hopefully quick, final question, and then we can take the conversation to a breakout session for those that are interested in continuing going into deeper detail. Just from each of your perspectives, Merce more on the Dataverse side, James on the OpenDP side, wild success. What does wild success look like for Dataverse? You have all the data in the universe. You have helped produce interesting scientific insights that are reproducible. How do you really define success, and what's in the way? What do you need to do to get from here to that success definition? And then similar, James, for you.
Well, as I mentioned as part of the presentation, that Dataverse is more mature. I mean, with OpenDP, we just started the project in the last years or so. Although there were projects, differential private projects that came prior to that led into OpenDP. But Dataverse has been now for about 15 years. And so to some level, there's been already a lot of success. I consider a lot of success. I'm part of it. So there is success at different levels. One is that it has created a community, and a community of not only programmers, developers, contributors to an open source code, but also of researchers, data practitioners, archivists, librarians, quite a variety of different people that work with data, right? In a way that they are all interested in making it easier to share data, but also in a responsible way. That they are interested in making science more open. That are interested in reproducibility and verifying any claims, any science results, but also claims that would be used for policy making, right? This is already being created. We want it to grow, but there is already part of that as a success. And then the more data the better, but at the end is the goal is to improve how we do research, how we learn about the world, how we get insights from those data. And it's not about only, to me, the amount of data, but also being very aware of the quality, right, and the interoperability of that data. So that first, that it has to be well described, so we understand what that data set is, and that's why Dataverse is not just a data lake, or just not a file folder to put all these files, right? It has a lot of a whole layer to help you provide more information and documentation and so about the data set, but also those data sets will be used not only reusable by others, because now they are understood, but also reusable by machines, by other systems, right? So they have that interoperability that allows for machine learning, for AI solutions, for workflows that improve or accelerate the discovery. That's for Dataverse part, and then maybe James, if you want to see for OpenDP, what would be the success? We're gonna launch the MVP this fall, at the end of this fall. So first success, launch the MVP, right?
So it would be nice so I have a positive answer and a negative answer. Quickly, science. I've spent my career working on tools that make scientific research better. And so, science is sort of my muse, and I think that science is one of the pillars that allows sort of society to make the human condition better. So I think that if you build systems that allow you to merge together lots of different sensitive information, or give researchers access to stuff they ordinarily would never get access to, we will get new results, we will get new understandings, we will drive knowledge, in legitimate ways fast. But I also completely worry that, as the things we measure get more and more complex and detailed and ethically, harder to protect, that there will come these crises, there will come these scandals where data that was donated for the scientific good may be leaks, or things that people, donated to science, donated to researchers, gets out there in the world, gets lost through, gets leaked through models. And then suddenly the population doesn't trust science anymore, or doesn't trust researchers, or is worried that, I'm going to lose all of my individual level information if I keep participating in the scientific paradigm. So the negative answer is I hope the technology that we're building and the research work that's done in differential privacy and the systems that engineers are building can outpace that sort of apocalypse that will happen if there isn't good privacy preservation in the future. So avoid that sort of, nuclear scandal that destroys people's confidence in participating in science for the public good. So not seeing that is the thing that keeps me up at night.
Well, thank you very much. And again, for those interested, we can move to a session, clear off the main stage here, make room for, I think Adam is coming next. And so we're going stage left. Thank you, James. Thank you, Merce. Really, really appreciate the time. And again, for anybody who is interested, we can move over to a session.
Thank you, Chris and Hugh and Mo. It's been fantastic to watch.
Yeah, thanks everybody. Thanks.
Yeah, thank you, Mo. Cheers.
So Mo asks, do companies that grant internal access to their data to their own companies have tools for privacy preservation? Some of them do. Like typically what you see is some sense of like, oh, we're going to log all the queries, and then somehow we'll be able to look at those logs and we'll judge whether or not those queries look suspicious. And I'll say that's good practice, but it's certainly not infallible. For the software-ish, for the engineers among us, I'll say that trying to understand whether you are learning individual level information from queries is NP hard. So basically, it's an uncomputable problem to look at a series of queries and then go, okay, what were they actually trying to do with those queries? Is there some clever way to recombine them and tease back out individual level information? So of course it would, logs are good for saying, did you do a query that only had one person could possibly be the answer to that query, but it's not a fail-safe. And what we've seen is that one of the sort of among the first 3 or 4 implementations that went live in industry of differential privacy was Uber's differential privacy platform. And they built this not as a portal to the outside world. They wanted a portal to protect their internal data from their own employees, because they'd had a number of scandals where people were doing unethical things or possibly, using their privileged access to snoop on individuals. And so they built a differential privacy library to sort of hide their own data from, hide data that's in this silo here from people who should be in this silo over here. And we've seen that in other corporate settings where when there are restrictions in place that certain types of people should not be able to share or join data in the raw, then increasingly we're using some form of privacy preserving technology, including differential privacy, to formally make that privacy within institutions more explicit. So I think that's a strong use case as the researcher outside analyst use case that Mercedes and I were talking about. That sort of internal ethics is a strong motivator of a lot of this literature.
In that context, are there regulatory compliance questions that pop up? And we've got all these regulated industries, and certainly privacy is a right that is increasingly assumed to exist. Are there, in that Uber example, having built their own differential privacy internally, is that something that you would expect to evolve over time and be more of a industry standard and even expected for certain types of compliance if you have certain types of data? Or is that just they're hit with some external scandals and trying to do some internal house cleaning or housekeeping? What do you think on that?
Mercedes?
I mean, well, first, regulatory, of course, that it is important, and it depends if. So we separate the tools for running differential privacy queries, and also the infrastructure for saying how we're collecting the data, where are we depositing the data, what are we doing, what are the agreements, and everything that applies to the security requirements, other requirements that would apply depending on what the sensitivity of the data, right? That based on what the regulations that apply to that data set, and that's one thing needed to even have access to, for example, OpenDP even have access to that data. You need to make sure that it's accessing in a secure environment that follows the regulatory that apply to that data set, right? The regulations that apply to that. But in terms of if then differential privacy could become part of the norm, I think I think that it cannot be everything. Maybe James has another answer, but there is some. I mean, if we take the example of GDPR in Europe or other cases in HIPAA, there is some for HIPAA for patient data also, or student data, that there is some information that you still that you need to collect under certain conditions that will continue to apply. The question is, how can you make use of that data for getting insights? And that's where the differential privacy can help to do that, following the laws, the regulations apply to that data set. That I think, but it's still there is a level. There is some privacy laws that protect the individual in a way that differential, that they're more about, well, I do not want the data to be collected, any data to be collected about me. I want to be forgotten, and you can. I think it would be naive to think that one tool will solve all those problems, right? I mean, I think that, so there is an enforcement that has to be done by policy plus the technology, have the technology to help support that policy. James, do you want to?
Yeah, I want to talk about
that
in the loosest possible way, but just say that that one of the privileges of working at Harvard has been, and with OpenDP, has been the giant community of researchers who you think would never be involved in a project and then get sucked in. And so we've had the OpenDP group has worked a lot with legal researchers, technical legal researchers, particularly at like the Berkman Klein Institute, who study sort of the intersections of technology and policy. And they've spent a lot of time like working out whether the mathematics of differential privacy can bridge and explicitly satisfy things like GDPR or HIPAA. Also, whether it satisfies Title 13, which is the enabling legislation for census. And what we have, I think the summary answer is differential privacy generally satisfies good laws that are written sort of nebulously and allow the best practices to sort of satisfy what is needed, and bad laws are laws that tend to enshrine whatever anybody thought was the state of the art at moment A, because pretty soon that's no longer state of the art.
Right.
So I think hopefully over time that lesson will be brought on board, and hopefully legal policy will be, you should do the things that are considered state of the art, and you should use the best practices that are understood by certain communities. But we've seen some of it. Title 13 is a great example where if people aren't aware, Census realized that they had a problem under this idea that you can't release too many statistics, otherwise you can re-identify the underlying data. And they've published some survey results that they worked out where they're releasing billions and billions of underlying tables that are each aggregates on basically 300 million individuals living in the United States. And so it is possible, if you have enough computational power, to work out what some of the underlying data must have been. And when they realized that, well, then we're going to have to use differential privacy, and they're going to use differential privacy for everything. So once they worked out that differential privacy could satisfy Title 13, which is the explicit legal enabling legislation that says what Census has to be able to do in their products, then they decided, everything we release in the next decennial census, which is being collected now, fill out your census forms, is going to be a differentially private product of a giant differential privacy system. And they've been driving a lot of this work in the research community.
Are they involved in OpenDP?
Yes, they've been a supporter of the OpenDP project. They've provided grant support. I'm amiss. I had it in my slides, but I didn't mention it. They're also heavily supported by the Sloan Foundation. So the Sloan Foundation and Census and NSF have been major contributors. And I think even more than sort of helping to fund the research, has been engaging with them to sort of understand like what are their problems, because that's right. Sort of motivated a lot of the technology that we've been building. Like if it's not going to work for Census, then it probably isn't quite the right answer, because they've got a very, very clear and understood use case that is used by thousands and thousands of researchers.
Yeah, exactly. Much of the use cases where they're driving the requirements are a lot based on that.
Right. And this MVP that Mercedes was saying that Dataverse is building is driven by the Australian census, for example, as a first example use case.
Oh, interesting. I didn't catch that connection.
I didn't make it explicit, but yeah, that's the. But that's well, I think if we prove that this can be useful for these cases, I think that we'll have it's a good start to then generalize for others.
Yeah. Alexi has asked this question twice. Can I try to answer it because would be hard for me to type out, about what happens if multiple adversaries are all asking the same question and they're in collusion. That really has to do with your threat model. So if you believe that's your threat model, that is, you don't know who's asking questions and you don't trust them not to collaborate, then the way you do budgeting, Alexi, is you're going to have to think about the budgeting of all the queries that come across all possible researchers. And you're going to have to put that all together into one global budget. And that's the only way you'll be able to safeguard privacy. And at some level, that's sort of what Census is doing. They happen to have, 300 million records in their data set. They're thinking about everything's going to be released to the general public. So everything comes from one budget. In settings where your threat model is different, like where you think, oh, okay, these people are honest but curious. They're sort of, I can trust them to not say collude if they sign a terms of use. Maybe like academic researchers who want to do a little bit of exploratory data analysis. There you can give individual budgets to individuals, assuming you say, okay, well, the budget comes to you only under the explicit promise that you won't release that information so that other people can see it. It's for your own use until perhaps, like as in Mercedes' case, you might get access through an IRB or something like that later. So it depends on the threat model. And yes, if the threat model is you're worried about collusion, then yeah, you have to do budgeting globally and not individually.
But the issue is we will have to, if we're dealing with data that are even remotely public or publishable, like the statistics on those data, there will be collusion.
Yep. So that's, say, the model that Census uses. And yet they still, are able to release their, 10 billion summary tables on 300 million records, so with accuracy that they deem acceptable. Right. So
thank you.
One thing to keep in mind, everybody worries about the noise and the budgeting, and it is true, but generally speaking, as a rule of thumb, the noise that you're adding collapses as something like 1 over n. So as your data set expands in size n, the noise that you have to add shrinks by a factor, but by 1 over n. And if you say, well, that still seems large, realize that sampling error collapses as 1 over square root of n. So sampling error, that is the uncertainty that you've added to your answer because you only collected a finite sample, is collapsing slower than differential privacy is to. So basically what I tell people is, if you're really, really worried about differential privacy noise, go collect some more data. Don't bug me about privacy. So that also speaks to your point. Like if you're worried about global budgeting, okay, well then, go get more data if you need to ask more questions or something like that.
I'm rather thinking of an attack surface and the threat model, as you pointed out. Yeah. So thanks.
Right.
Yeah. Good.
Cool. Thanks for bringing up that question.
Others, feel free to jump in, both chat or in video as Alexi did.
Sarah brought up Berkman Klein, and I talked about them, but Mercedes, you probably had more interaction if you wanted to talk about like that kind of interaction. I don't know if there are others here who are interested more in sort of technology and policy more than code bases and stacks. Do you want to talk about those questions that exist in sort of data and privacy, data and policy?
Maybe I think I'm missing the question. Which are you referring to a question in the chat, or
yeah,
are you
Sarah
referring
says that we already
general
answered her question about whether we collaborated with Berkman Klein, which we have, but I didn't great as detail about what we do with them. So if
right. Well, so at a number of levels, we've been collaborating with them. For in general, for just the data sharing part and the using Dataverse and the integration of Dataverse with OpenDP, we're collaborating for them to review also the terms that the user have to agree to use all those things. What is it needs to be aware of? What is it responsible? I mean, both the users as the data owner that would create differential private releases, would deposit the sensitive data and be able to and understand what are the responsibilities of the depositor, but also for the end user, what are the events that they need to go through. Then also we review this. I talked briefly about this concept of data tags, so the different levels of sensitive data. So we also have worked with them to understand how each one of these levels from blue, green, and yellow, and orange, red, and crimson, how they map to either to a policy or a privacy law or some other regulation, so that for this type of data sets that this law applies, this would be the level of sensitivity, and therefore that's the data tag that we would assign. And we would know by assigning this data tag, the Dataverse knows what needs to happen to that data, what are the requirements that are set to that data, and how it needs to be, the security requirements and the access requirements, and whether they need a data use agreement or not to be shared. So I hope that helps. If there is a specific question, let me know.
I feel like I've at least been able to voice over some of my questions, so I don't want to steal the show here. You guys are really the experts, and maybe you could. Is there anything that we didn't touch on the obvious omission of the question we didn't ask because we weren't thinking of it?
Chris, is it okay if we ask you a question? Not
you bet, yeah.
Just how do you see Red Hat playing a role with projects like this, with OpenDP, Dataverse, or with or differential privacy, or is that something that to be discussed in a different session altogether?
Well, it's
now that you understand more what we're doing. I mean, we've been talking about those projects and. Communicating with a lot of people, Red Hat, but since this is the Red Hat Research Day, I just want just like to hear from you. What do you think?
Why are we engaged? There's a lot of sort of think of this as layers of the stack. I think of this as layers of the stack, and so there's pieces inside Dataverse. There's actual plain old everyday distributed data persistence requirements. So we got to store the data somewhere. And so in the very earliest stages of Dataverse, we were looking at just the basics. Are there things that we can do to help support Dataverse as a large distributed storage persistence layer? So say Ceph, for example, or just to store data. There's
we integrate with that,
right, exactly. But you could say that's boring in the sense that that's just applying a well-understood piece of technology to a well-understood problem domain, which is how you store data, large data sets. To me, the broader interest is, one, we're open source focused. So things like OpenDP are open source projects that we can be directly involved in. Dataverse, community project that we can be directly involved in. And the pieces that we could pull together that are seen, at least to me, represent building blocks that I think we need commercially to create an environment where we can take insights from data that we don't necessarily own, or gather insights from data that we don't necessarily own. And really specifically in a customer context, they run our software. They generate a lot of data from running our software. Interesting questions about who owns that data. But generally speaking, most of our customers would feel like that's their data, and they'll have differing levels of comfort with where, when, and how they share that data with us. Certainly in a support case, we tend to upload system logs pretty consistently, and we do a lot of work to ensure that we remove the equivalent of PII, so IP addresses and host names and things like that. But what can we do in this both open source context, so we build open source based solutions, and commercial context where there is a lot of data, some of which is very germane to the operations of our own systems, where we could create insights which we share back with our broad user community based on data that isn't directly accessible to us. And then, you know, the other questions I think are really what are we, well, that's probably the most direct, interesting area for us. And then there's a bunch of broader societal questions, which is kind of what's our responsibility in this space to be involved and help, just based on concerns for privacy while wanting to be from data, aren't limit commercial connection we have to our customers, but more broadly, science and discovery. So the broader one, a good thing that we should do to the degree that we have the capabilities and resources and whatnot. The narrower one, it's speculative. There's many ways to solve that challenge, and some are really more a EULA, a policy. We promised we won't do anything bad with your data. That doesn't seem to hold up very well over time, and so we're interested in more algorithmic scientific approaches to data sharing and data insights gathering. So that's probably the real interest that we have.
That's great. Thank you. Thanks a lot.
Yeah, absolutely. I actually do need to drop at this point. I'm at my time allotment, and I think we may have another session. I'm not sure how. I think we can run sessions in parallel, but so if there's more conversation, I think you're welcome to stay. Otherwise, thank you very much, Merce, James. I really appreciate it. And Mo, I love the sort of backdrop of animated information that you've provided here.
Thank you, Mo.
And someday we'll get back in person and be able to share a beverage and more conversations. I look forward to that.
Thank you again so much.
Me too. Thanks, everybody. Bye.